primary concern is a detached conduit and bonding lug on a wet niche luminaire forming shell in a swimming pool. Removing the forming shell can risk displacing backfill gravel and causing structural damage around the pool. Considering alternative solutions is important. Firstly, consider external bonding. This involves installing an external bonding strap connecting the conduit and bonding lug outside the forming shell. This method requires drilling access holes through the concrete walkway. Secondly, attempt reinserting the existing bonding lug. Carefully use pliers or a hook to reinsert the number 8 bonding lug back into the forming shell. Secure with a new lock nut. Thirdly, explore modifying the forming shell. Create a small opening in the forming shell using a chisel or hammer and chisel. Insert the bonding lug and conduit through the opening and secure them. Seal the opening with an appropriate waterproof sealant. If you choose to proceed with any repair, safety should be prioritized. Turn off all electrical power to the pool equipment. Allow the water level to drop below the niche opening. To access the forming shell, remove the luminaire and any access covers. Use a pry bar or similar tool to carefully lift the forming shell from the opening if necessary. To reconnect the conduit, insert the conduit into the forming shell and tighten the lock nut. To reattach the bonding lug, use one of the alternative methods. Reinstall the forming shell. Carefully reinsert the forming shell into the opening and secure it in place. Check for any voids or gaps and fill them with a suitable material. When performing these repairs, use waterproof connectors and sealant to ensure weathertight connection. Document the work performed and take photos for future reference. Consider hiring a qualified electrician or pool contractor for this repair. When dealing with pool electrical systems, ensuring proper bonding and grounding is extremely important for safety. The forming shell is a critical component in the pool's grounding system, providing a connection point for the bonding conductor. This conductor helps equalize the electrical potential between different metal parts of the pool, reducing the risk of electric shock. A detached conduit and bonding lug compromises this grounding system. The National Electrical Code, or NEC, provides specific requirements for swimming pool electrical installations, including bonding and grounding. These requirements are designed to minimize the risk of electrical hazards. When a bonding connection is compromised, it can create a potential difference between the pool washer, metal parts, and the surrounding earth. This potential difference can lead to electrical current flowing through the water or through a person in the water, resulting in electric shock or even electrocution. Therefore, repairing the detached conduit and bonding lug is crucial for ensuring the safety of the pool and its users. Several factors can contribute to the detachment of the conduit and bonding lug. Corrosion is a common issue in pool environments due to the presence of chlorine and other chemicals. Over time, corrosion can weaken the connection between the bonding lug and the forming shell, leading to its eventual failure. Physical stress can also cause the connection to break. Movement of the ground around the pool, settling of the pool structure, or accidental impact can all put stress on the conduit and bonding lug, causing them to detach. Improper installation can also be a factor. If the conduit and bonding lug were not properly secured to the forming shell during the initial installation, they may be more likely to detach over time. In addition to the alternative solutions already mentioned, consider the following points. Thoroughly inspect the forming shell for any signs of damage or corrosion. If the forming shell is severely corroded or damaged, it may need to be replaced entirely. Ensure that all bonding connections are tight and secure. Use appropriate tools and techniques to tighten the lock nuts and other fasteners. Apply corrosion-resistant coating to all metal parts of the bonding system. This will help protect against future corrosion. Consider using a bonding jumper to connect the forming shell to other metal parts of the pool, such as the pool pump motor and metal fencing. This will help ensure that all metal parts are properly bonded together. If you are not comfortable performing these repairs yourself, it is best to hire a qualified electrician or pool contractor. They have the knowledge, skills, and experience to safely and effectively repair the bonding system. When selecting an electrician or pool contractor, make sure they are licensed and insured. Check their references and read online reviews to ensure they have a good reputation. Ask them about their experience with pool electrical systems and their knowledge of the NEC requirements. Before starting any work, get a written estimate that includes a detailed description of the work to be performed, the materials to be used, and the total cost of the project. Once the repairs are complete, have the electrician or pool contractor inspect the bonding system to ensure it is working properly. They should also provide you with documentation of the work performed, including photos and a written report. By taking these precautions, you can help ensure the safety of your pool and its users. Remember that pool electrical systems are complex and potentially dangerous. It is always best to err on the side of caution and seek professional help when needed. To elaborate further on the alternative solutions, let's delve into the specifics of each. The external bonding method involves creating a new bonding connection outside of the existing forming shell. This approach is particularly useful when the original bonding lug is inaccessible or severely damaged. The first step is to identify a suitable location on the concrete walkway near the forming shell where you can drill access holes. Choose a location that is easily accessible and that will not interfere with pool traffic or other equipment. Using a hammer drill with a concrete drill bit, carefully drill 2 holes through the concrete walkway. The holes should be large enough to accommodate the external bonding strap and the necessary hardware. The external bonding strap should be made of copper or another corrosion-resistant material. It should be long enough to reach from the conduit to the bonding lug, with enough extra length for making connections. Attach the external bonding strap to the conduit using a suitable connector, such as a bonding bushing or a grounding clamp. Ensure that the connection is tight and secure. Attach the other end of the external bonding strap to the bonding lug using a similar connector. Again, ensure that the connection is tight and secure. Once the external bonding strap is in place, seal the access holes with a waterproof sealant to prevent water from entering and corroding the connection. The sealant should be compatible with concrete and copper or other bonding strap materials. The reinsertion method involves attempting to reinsert the existing number 8 bonding lug back into the forming shell. This approach is only feasible if the bonding lug is still in relatively good condition and if the opening in the forming shell is accessible. Carefully inspect the bonding lug for any signs of damage or corrosion. If the bonding lug is severely corroded or damaged, it should be replaced with a new one. Use pliers or a hook to carefully manipulate the bonding lug into position. Be careful not to damage the bonding lug or the surrounding forming shell. Once the bonding lug is in position, secure it with a new lock nut. Tighten the lock nut using a wrench or pliers. Ensure that the lock nut is tight enough to hold the bonding lug securely in place, but not so tight that it damages the forming shell. The modifying the forming shell method involves creating a small opening in the forming shell to allow access to the bonding lug and conduit. This approach is useful when the original opening is too small or inaccessible. Carefully plan the location and size of the opening before you start cutting. The opening should be large enough to allow access to the bonding lug and conduit, but not so large that it weakens the forming shell. Use a chisel or hammer and chisel to carefully create the opening in the forming shell. Be careful not to damage the surrounding concrete or pool structure. Once the opening is created, insert the bonding lug and conduit through the opening. Secure them in place using appropriate connectors and hardware. Seal the opening with an appropriate waterproof sealant. The sealant should be compatible with the forming shell material and the surrounding concrete. In addition to these alternative solutions, consider the following additional tips. Always use waterproof connectors and sealant to ensure weathertight connection. This is especially important in pool environments where there is constant exposure to water and chemicals. Document the work performed and take photos for future reference. This will be helpful if you need to perform repairs again in the future. Consider hiring a qualified electrician or pool contractor for this repair. They have the knowledge, skills, and experience to safely and effectively repair the bonding system. When working with electrical systems, always follow proper safety precautions. Turn off the power to the circuit before starting any work. Use insulated tools and wear appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. The NEC provides specific requirements for swimming pool electrical installations. These requirements are designed to minimize the risk of electrical hazards. It is important to be familiar with these requirements before performing any electrical work on a swimming pool. Some of the key NEC requirements for swimming pool electrical installations include bonding, grounding, ground fault circuit interrupters, or GFCIs, and wiring methods. Bonding refers to the practice of connecting all metal parts of the pool together to equalize their electrical potential. This helps to prevent electric shock by ensuring that there is no voltage difference between different metal parts. Grounding refers to the practice of connecting the electrical system to the earth. This helps to provide a path for fault current to flow back to the source, tripping the circuit breaker and preventing electric shock. GFCIs are devices that are designed to protect people from electric shock. They work by monitoring the current flowing through a circuit and tripping the circuit breaker if they detect a leakage of current to ground. Wiring methods refer to the types of wiring that are allowed to be used in swimming pool electrical installations. The NEC specifies that certain types of wiring must be used in wet locations such as swimming pools. By following these NEC requirements, you can help ensure the safety of your swimming pool and its users. Remember that swimming pool electrical systems are complex and potentially dangerous. It is always best to err on the side of caution and seek professional help when needed. To provide more context to the NEC requirements, let's consider some specific examples. NEC Section 680.26 covers the requirements for bonding of swimming pools. This section requires that all metal parts of the pool, including the forming shell, metal conduit, metal fences, and metal ladders, be bonded together using a number 8 solid copper conductor. The bonding conductor must be connected to a common bonding grid, which is a network of interconnected conductors that provides a low impedance path for fault current to flow back to the source. NEC Section 680.23 covers the requirements for underwater luminaires, or pool lights. This section requires that all underwater luminaires be listed for use in swimming pools and that they be installed in accordance with the manufacturer's instructions. Underwater luminaires must also be protected by a GFCI. NEC Section 680.21 covers the requirements for receptacles or electrical outlets near swimming pools. This section requires that all receptacles within 20 feet of the pool be protected by a GFCI. The receptacles must also be weatherproof and must be installed at least 12 inches above the ground. These are just a few examples of the many NEC requirements for swimming pool electrical installations. It is important to be familiar with all of these requirements before performing any electrical work on a swimming pool. In addition to the NEC requirements, there are also local codes and regulations that may apply to swimming pool electrical installations. It is important to check with your local building department to determine what codes and regulations apply in your area. By following the NEC requirements and local codes and regulations, you can help ensure the safety of your swimming pool and its users. Remember that swimming pool electrical systems are complex and potentially dangerous. It is always best to err on the side of caution and seek professional help when needed. Considering the age of the pool, approximately 25 years old, several factors related to aging infrastructure become relevant to this repair. The original materials used in the forming shell and conduit may be nearing the end of their lifespan. Corrosion, as previously mentioned, is accelerated over time, especially with constant exposure to pool chemicals. The integrity of the concrete surrounding the forming shell may also be compromised due to age, leading to cracking or crumbling that can weaken the bond between the shell and the surrounding structure. Soil shifting and settling around the pool can also put stress on the underground conduit and connections, contributing to the detachment of the bonding lug. When evaluating repair options, it's essential to consider the long-term durability of the chosen method. A quick fix that doesn't address underlying issues may only postpone the problem. For example, simply reinserting the bonding lug without addressing corrosion or structural weakness may lead to another detachment in the near future. Therefore, a more comprehensive approach may be necessary, even if it requires more effort and expense upfront. This could involve replacing the entire forming shell or reinforcing the surrounding concrete to provide a more stable base. Another important consideration is the availability of replacement parts. If the original forming shell is no longer manufactured, finding a compatible replacement may be challenging. In this case, modifying the existing shell or using an external bonding method may be the only viable options. However, it's crucial to ensure that any modifications or alternative methods comply with current safety standards and NEC requirements. When reconnecting the conduit and bonding lug, it's highly recommended to use corrosion-resistant materials and techniques. This includes using copper or stainless steel connectors, applying a corrosion-inhibiting compound to all metal surfaces, and sealing all connections with a waterproof sealant. Additionally, consider using a flexible conduit instead of rigid conduit to reduce stress on the connections due to ground movement. Flexible conduit can absorb vibrations and minor shifts in the surrounding soil without putting excessive strain on the bonding lug and forming shell. Finally, after completing the repairs, it's essential to conduct a thorough inspection of the entire pool electrical system to identify any other potential problems. This includes checking the wiring, grounding, and bonding of all pool equipment, such as the pump, filter, heater, and lights. Addressing any other issues proactively can help prevent future problems and ensure the overall safety of the pool. In conclusion, repairing a detached conduit and bonding lug on an aging pool requires careful consideration of various factors, including safety, code compliance, material compatibility, and long-term durability. A comprehensive approach that addresses underlying issues and uses corrosion-resistant materials is essential for ensuring a safe and reliable repair.